discuss about measures of central tendency. Central tendency is a fundamental concept in statistics that refers to the center or typical value of a dataset. It provides a single value that is representative of a set of data points. The three most common measures of central tendency are the mean, median, and mode. Each of these measures give different insights into the data and is useful in different scenarios. It is of three types: mean, median, and mode. Mean. The mean, also known as the arithmetic average, is calculated by summing all the values in a dataset and then dividing by the number of values. It is widely used because it takes into account every value in the dataset. Now, let's discuss about types of mean. Arithmetic mean. The arithmetic mean is the sum of all values in a dataset divided by the number of values. It is the most commonly used type of mean. Geometric mean. The geometric mean is the nth root of the product of all the values in a dataset, where nn is the number of values. It is useful for datasets that involve rates of change or multiplicative processes. Harmonic mean. The harmonic mean is the reciprocal of the arithmetic mean of the reciprocals of the values. It is particularly useful for rates and ratios, such as speeds or densities.
Median. The median is the mid value when the dataset is ordered from smallest to largest. If the number of observation is odd, the median is the middle number. If the number of observation is even, the median is the average of two middle numbers. Steps to calculate. Arrange the data in ascending order. If the number of observation is odd, the median is n plus 1 whole divided by 2th value. If the n is even, the median is the average of n by 2 and n by 2 plus 1th value. For example, for dataset 2, 3, 5, 7, 11, the odd number of observation, median is equals to 5. Properties of median. Positional measure. The median is the mid value that divides the dataset into two equal halves. Robustness to outliers. The median is not affected by the extreme value, making it reliable for skewing data. Applicability. Sustainable for ordinal, interval, and ratio data, but not for nominal data. Calculation. For an odd number of observation, median is the middle value. For an even number, the median is the average of two middle values. Order dependent. Required data to be sought in ascending or descending order. Equal division. Split data into two equal parts with 50% of value below and 50% above the median. Mode. The mode is the value that appears most frequently in the dataset. A dataset may have one mode, more than one mode, or no mode at all if no number repeat. Example, for dataset 1, 2, 2, 3, 4, mode is equals to 2. For dataset 1, 2, 2, 3, 3, 4, mode is 2 and 3. Bimodal. Properties of mode. Applicability. Suitable for nominal, ordinal, interval, and ratio data, particularly used for categorical data. Uniqueness. A data set can be one mode, unimodal, more than one mode, bimodal or multimodal, or no mode if no value repeats. Position independent. The mode is determined by frequency, not by the position or order of value in the dataset. Insensitive to extreme values. The mode is not affected by the outliers or extreme values. Simplicity. Easy to identify in small dataset, especially when data is grouped or categorized. Non-numerical data can be used with non-numerical categorical data to identify most common category.
Comparing mean, median and mode, mean is the sensitive to outliers and the skewed data because it includes all the values in its calculation. It is useful for the data sets without extreme values and when all the values are equally important. And next we come to the median. Median is less affected by the outliers and the skewed data. It is preferred for the data sets with the outliers and the non-symmetrical distributions. Mode is useful for the categorical data where we want to know the common category. Next we come to the applications in real life. First is the arithmetic mean. Arithmetic mean can be applied in education, economics and business. Geometric mean can be applied in the finance as well as the growth rates. Harmonic mean can be applied in the speed and rates, densities and the concentrations. Median first is can be applied in the income and the wealth distribution, and next is the healthcare. Mode is also applicable in the market research as well as the quality control. There are some misconceptions now which we're going to talk about. Misconceptions about mean. The first misconception is the mean is always the best measures for the central tendency, but in reality it is not always the best and best measure, because for the skewed distributions or the data outliers, in such cases the median or the mode provides a better central value. And next misconception about the mean is the mean are always accurately represent the centered data. In reality, in asymmetrical distributions, the mean can be misleading. It's influenced by the extreme values. And next comes the misconceptions about the median. Misconceptions about the median. The first misconception is the median is only useful for the symmetrical data, but in reality the median is particularly used for the skewed distributions because it is not affected by the outliers and provides a better sense of the data central and location. Next misconception about the median is the median value must be always a value present in the data set, because for an even number of the observations the median is the average of the two middle values, which may not be an actual data point. Misconceptions about the mode. The first misconception about the mode is it always represents the center of the data. In reality, which states that the most frequent value which may not be near the center, especially in the multimodal distributions where the multiple values are equally frequent. And next misconception states that every data has a mode. Every data set has a mode, but in reality some data sets do not have a mode if no value repeats. Conversely, in some data sets can have the multiple modes like the bimodal mode or the multimodal distributions.